Now my dear students, we can see here the freezing point, question number 28, the freezing point depression Kf of benzene is 5.12 Kelvin kilogram per mole. The freezing point depression for the solution of molality that equal to 0.078 molal containing a non-electrolyte solute in benzene is, my dear students, here you can see this question is also asked in NEET 2020. Here we can see what is the formula which can use here, formula which can use here delta Tf is equal to Kf into small m. Here my dear students, here we can see the small m that equal to molality, and here Kf, it is called my dear students freezing point constant, freezing point constant. So here we can see the delta Tf is equal to Kf into small m. This is our first formula. Number second, we can see here, you can put the values of Kf. What is the value of Kf here? 5.12. And he wants the freezing point depression constant of benzene, means it's a Kf is equal to 5.12, molality that equal to 0.078. So my dear students, when you can put the values, then you can get the freezing point constant here, delta Tf. So put the values here, 5.12 multiplied by the 0.078, and my dear students, you can get the answer, that is 0.40. This is your answer for this question. Question number 28, answer is C. Now my dear students, you can see here, this question is also as NEET 2020, only multiply because their molality are given. So you can get the 0.40 Kelvin. Now we can go to the question number 29. Here my dear students, if molality of the dilute solution is doubled, the value of molar depression constant Kf will be. Here what is the concept? We can see here concept, my dear students. Here molar depression constant Kf. Here this is a molar depression constant Kf is the constant so it's not depend upon concentration. So it is not depends upon the concentration. So my dear friends, here your answer is C. Question number 29, unchanged. Kf is unchanged because Kf is a constant and not depends upon concentration. Question number 29, answer is C. Now we can go to the question number 30. Here we can see at 100 degrees Celsius, the vapor pressure of the solution of 6.5 gram of a solute in 100 gram water is 732 millimeter. If Kp is equal to 0.52, the boiling point of this solution will be. Here my dear students, we can apply the formula. And what is the formula? That is P0 minus Ps upon P0 that equal to N2 upon N1. Here we can see here P0 is equal to vapor pressure of pure solvent. Here you can see in the numerical, that is 732 millimeter. Vapor pressure of solution is 732 millimeter. So P0 is equal to, here it is not given us. So it is a 1 atmosphere, and what is the 1 atmosphere is equal to 760 millimeter mercury. Because this 760 millimeter mercury is equal to 1 atmosphere, and my dear friends, you know that in 1 atmosphere, vapor pressure is equal to atmosphere atmosphere pressure, then that point is called boiling point. What is the boiling point? Boiling point of that point, my dear students, in which vapor pressure is equal to atmosphere pressure. So here, my dear students, you can see here vapor pressure of pure solvent that equal to 1 atmosphere. So you can write here 760 millimeter mercury, and what is the vapor pressure of solution? That is 732 millimeter mercury. And what is the N2 and N1? Here, first of all, we can calculate the here N2. So number of moles we can calculate. Then you can put second formula. Here this is our first formula. We can use two formula in this question, so we can get the answer. First of all, we can calculate here N2. N2 is the number of moles, and this is the number of moles of the solute, and these are the number of moles in the solution. And here in this solution we can, if this pure, it's a number of moles of water. So my dear students, you can put here P0 760 minus 732. These values are putting, and 760 that equal to N2 upon N1. N1 here you can see the 100 gram of water. So here N1 that equal to W upon M. So it's 100 gram upon 18. So my dear students, you can put here 100 upon 18. So when you can solve this question, N2 that equal to N2 is equal to 760 minus 732, it is 28, multiply by this 100 and divided by this 760 and multiply by this 18. So you can calculate this N2, and then you can get the 0.2046. This is 4-digit number. After decimal you can get. So my dear students, here N2 is equal to 28 into 10 upon 760 into 18. So this is the number of moles, N2 is the number of moles. Now we can take the second formula, and in second formula, my dear students, that is delta here boiling point. So when you can get the boiling point, you can see the delta TB. Delta TB is equal to KB into small m. So my dear students, you can see this formula also. Delta TB is equal to KB into small m. And when this, in this formula we can see the delta TB. What is the delta TB? Delta TB that equal to boiling point of the solution minus boiling point of the pure solvent. Boiling point of pure solvent and boiling point of solution. So it is called, my dear students, delta TB. So delta TB is equal to TB minus TB0. When you can take this formula, delta TB is equal to KB into small m. You can see here, my dear students, m means number of moles. You can get N2. So here we can see the this TB, delta TB, when you can TB minus 100, you can put here, because it is a boiling point of pure solvent is a water, and boiling point of water is a 100 degrees Celsius. So you can put in place of delta TB, TB minus 100, and that equal to KB. What is the values of KB? Here you can see values of KB is equal to 0.52. So 0.52, and what is the molality? Here you can see the molality is 0.046, 0.0204. Okay, and now this molality in 1000 upon, this is the 100, because 100 gram of water, you can take the 100 gram water. So my dear students, you can see that TB that equal to, when you can divided these values, and you can get the 0 point, you can replace this point, 2 0 are placed, here you can replace this point, you can get the 1 2 3 4, 1 2 3 4, and 1 2 3 are cancelled with this one. So you can get the 1 2 3 4 5. So my dear students, this 204 is multiplied by this 52 and get the point after the 4. 1, 2, 3, 4, 5. So, my dear students, you can get the answer is 1.06 for this solution. Now, TB is equal to, when this minus 100 go inside, then 100 plus 1.06, that is the TB. And what is the TB, my dear students? This is the boiling point of solution, because here you can see in this question he has the boiling point of solution. So, my dear students, you can see here 100 plus 1.06, then you can get the 101.06, or approximately you can get the 101 degrees Celsius. This is the boiling point of the solution. So, my dear students, question number 30, you can go the answer C. Answer question number 30, you can go the answer C. Now, my dear students, we can see the question number 31. 200 milliliter of an aqueous solution of a protein contains its 1.26 gram. The osmotic pressure of the solution at 300 Kelvin is found to be 2.57 10 to minus 3 bar. The molecular mass of protein will be. Here, my dear students, question number 31, we can see the concept and formulas. Question number 31, you can see the, first of all, here osmotic pressure. So, in ideal solution, PV is equal to nRT you can take, and this P for osmotic pressure. So, you can also take this pi V is equal to nRT, and N is the number of moles. So, my dear students, N is equal to W upon M. So, this formula pi V is equal to W St upon as the solution constant upon Mb. In this way, for the osmotic pressure, we can use this type of formula. Pi V is equal to Wst upon Mb. Here, my dear students, when we can see the osmotic pressure, here M is the molar mass, you can calculate the molar mass. So, M go to the pi B and pi B inside, percent in below, then Wst. So, your formula become M is equal to Wst upon pi B. Now, my dear students, here we can see that M is the molecular weight and here molar mass of molecular weight. You can see that W is the weight. So, my dear students, you can see here we can put the values. W that will do 1.26 gram. Here S or R both are same, that is 0.083. Temperature T is the 300 Kelvin, and you can get the this as T and volume V. Here volume is, my dear students, that is 200 milliliter. But here you can take the volume in liter. So, this is divided by 1000 and convert into liter. Now, we can see here, you can put the formulas, you can put the values. Small m that equal to W, W is the 1.26 multiplied by the S is the 0.083 multiplied by the temperature 300 and divided by 200 upon 1000. So, my dear students, because here volume is taken, so 1000 go in upper side and this is divided by 1000 upon 200, because here 200 upon 1000 means 1000 go in upper side, 200% below side, multiply by the osmotic pressure here pi. Where is pi? We can see the pi, that is 2.57 10 to the power minus 3. 2.57 into 10 to the power minus 3. You can put the values of in this formula, my dear students, and when you solve this question, here 1.26, 0.083, into 300. This is a temperature in Kelvin. Here, my dear friends, into 1000, because 1000 is coming up above side, 2.57 times 3 into 0.2. Then you can calculate that this is 61038. This is gram mole inverse, and you can get the answer. So, my dear friends, answer is D. D option is the correct option for this question. Question number 31. Here we can see the number 1 formula, that is pipe. My dear students, dilute solutions are the ideal solutions, and these solutions obey the ideal gas equation, or behavior of the solution is same as a ideal gas. So, we can pi b nRT, PV is equal to nRT is converted to pi b is equal to nRT. Here N for the gaseous conditions, and in solution we can put the S. If this S is not given, here R or S is not given, here given in R, you can put here R, no problem at all, because value is same. So, my dear students, you can see here concept and formula and get the answer. Now, we can see the question number 32. Here, my dear students, question number 32, a solution of sucrose, molar mass is given 342, has been prepared by dissolving 68.5 gram of sucrose in 1000 gram of water. The freezing point of the solution obtained will be Kf for water, that will be 1.86 Kelvin kilogram per mole. And what is the concept and formula? My dear students, here we can see the formula and concept, because here freezing point of solution, he want the freezing point of solution. Then first of all, you can calculate that delta Tf, that is Kf into small m molality. And my dear students, what is the molality? Molality is given by small w into 1000 upon small m, molecular mass of the solute, into capital W weight of the solvent, and that is gram, because here 1000 is placed above side. So, you can put the values in this formula, delta Tf, that equal to Kf multiplied by this small w into 1000 upon small m into capital W. When you can put the formula Kf, what is the Kf? 1.86 here values, multiply by the small w, that is small w is 68.5 gram, it is a solute, weight of solute, and weight of solute is 68.5 gram, sucrose dissolved in 100 gram, it is a solute, my dear students, and it is a solvent. So, here 1000 gram, upon here you can see the small m is the molecular weight, here you can see the molecular weight, that is 342, and multiply by the weight of solvent, and here weight of solvent is 1000. Now, my dear students, when you solve this numerical, this 1000 cancel, here you can see the 0.2, here this point is also cancelled, and here these are the cancelled, but you can get the 1000 below side. So, when you solve this delta Tf, you can get the delta Tf 1.86, here 1.86 is converted to 186, 186 multiplied by 685 and divided by 342 into 10 to the power minus 3. So, my dear students, delta Tf, you can get the delta Tf by the solving of this 0.372 degree Celsius. Now, here he wants the freezing point of solution. Now, what is the delta Tf? It is a change in freezing point. Freezing point of solvent, that is 0 degree Celsius, is always greater than the freezing point of the solution Tf. So, 0 minus 0.372, and you can get the delta Tf, and that delta Tf is equal to minus 0.372. Now, my dear students, this is the answer. So, question number 32, your answer is A, minus 0.372 degrees Celsius. Now, my dear students, we can go to the question number 33. During osmosis, flow of water through a semi-permeable membrane is, it is a theoretical question. You all students, you know very well what is the osmosis. My dear students, osmosis is the process in which only solvent particles are migrate, not solute particles are migrate. So, my dear students, here in semi-permeable membrane you can see here that is the from solution having lower concentration only and get the flow of water, because here when you can see the semi-permeable membrane is present here. Here the solution, and we can say dilute solution, and here this is a solvent. You can say the solvent particles are migrate through this SPM, semi-permeable membrane, because here solvent is a water, concentration of water is higher, and here my dear students concentration of water is lower. So, it is a dilute solution, but is it solution? So, solvent particles are migrated. From solution having lower concentration only solvent particles are migrated. When you can get the two solution, here solution number 1, here solution number 2. Solution number 1 is a dilute solution. So, my dear students, it is called low concentrated solution or lower concentration solution. So, solvent particles are migrated through from this and this side, lower concentration. Dilute solution lower concentration, it is a higher concentration. So, molecules are migrate through lower concentration to higher concentration. Lower concentration, it means, my dear students, water molecule concentration of water is greater than solute. Here concentration of water is lower than solute. So, you can see that only water molecules are migrate. So, migration is solution 1 to solution 2, not solution 2 to solution 1, because we can take here solution 1 is a dilute solution. So, water molecule is in axis. So, it is a migrated. So, my dear students, in this way you can get the from solution having lower concentration only water flow through semi-permeable membrane. This question is asked in 2006 NEET exam, my dear students, and it is in this question we can explain the osmosis, what is osmosis and flow of water. Now, we can see here question number 34. Here, my dear students, question number 34, 1 gram of a non-electrolyte solute must dissolve in 51.2 gram of benzene. If the freezing point constant Kf of benzene is 5.12 Kelvin, the freezing point of benzene will be lowered by. Here, we can use the formula. Here, my dear students, we can use the delta Tf, that will do Kf into small m, and you can see the what is the small m, you can use the delta Tf, that will do Kf into small w into 1000 molality upon molecular weight upon capital W. Put the values Kf, what is the values of Kf? 5.12, small w, how many solute dissolved, that is 1 gram, and what is the molar mass of benzene? Here you can see the molar mass of benzene is given in your numerical, that is 250. What is the weight of solvent? Weight of solvent is already also given in this numerical, was dissolved in 51.2 gram of benzene. So, it is a 51.2 gram of benzene, and you can calculate the delta Tf. My dear students, point is replaced. So, 20 is placed, this point is replaced, you can put 10. 1, 2, 3, 30 are cancelled, 512 is cancelled, 11, and you can get the 10 upon 25. You can get the 10 upon 25. So, my dear students, delta Tf is equal to, that is 0.4, because point means 25 for the 100. So, it is a 0.4 Kelvin. So, delta Tf is equal to 0.4 Kelvin, you can get here. Now, this is a freezing point of benzene will be lowered, means he is only want the delta TF. Benzene is lowered by the 0.4 Kelvin. So my dear students, you can get the answer. Question number 34, answer is your B. B is the correct answer because you can get the 0.4 Kelvin. This question is also asked in 2006 NEET exam, my dear students. Now we can see the question number 35. Here, my dear students, you can see here, these are the isotonic solutions. What are the isotonic solutions? What is the concept and formulas? Concept and formula for isotonic solution, my dear students. Isotonic solutions are those solutions in which osmotic pressure and concentrations are same. You can see here osmotic pressure and concentrations are same, means pi 1 is equal to pi 2, osmotic pressure are same, and C1 is equal to C2, concentrations are also same. Then my dear students, you can put the formula W1 upon M1 is equal to W2 upon M2, and you can find out the molecular weight of second solute if you have weight and molecular weight of first solute. Then my dear students, you can find out the molecular weight of second solute. So here in this question, my dear students, you can apply this formula. How? Yes, we can see that W1 is that solute, my dear students, in which in formula you can get the molecular weight, that is W1. Here you can see that 10 gram and here molecular mass 60, means W1 is 10 and molecular weight is 60. Then you can see here, my dear students, W2 is a 5%. 5% means 100 in 100, 5 gram are dissolved. So in 1000, 50 gram is dissolved because here concentration is same. Per decimeter means per liter. So here it is converted to this 100 milliliter dissolved 5 gram. So my dear students, 1000 milliliter or 1 liter dissolved in 50 gram. So you can put here 50 upon, you can calculate the M2. Now my dear students, we can calculate the M2. We can calculate the M2 by this formula. M2 is equal to 60 into 50 upon 10. So my dear students, it is a 30,000 upon 10. So when you can divide this, you can get the 300. And my dear students, this 300 gram per mole, this is the correct answer for your question. So my dear students, you can go to the question number 35, you can go to the C option. Question number 35, you can get the C option, 300 gram per mole.